preview of last lecture. In last lecture, we are already started the second chapter, that is the pump, accumulator, intensifier, and valves. As far as pump is to be concerned, these are mainly the hydraulic pumps. And what is the main function of the pump? The pump is utilized to use the mechanical energy in order to convert the fluid pressure energy. Means by using the pump, we can convert mechanical energy into hydraulic energy or fluid pressure energy. Second element, that is the accumulator. Accumulator is a one kind of storage device which will store high pressurized fluid in one tank, one device, and that will supply that high pressurized fluid to the actuator, where fluid pressure energy is converted into mechanical energy. The next element, that is the intensifier. Intensifiers are those elements which are used to increase the pressure Hello, am I audible?
Yes, sir.
Okay. Intensifier are those elements which are used to increase the pressure on a hydraulic fluid, which is impossible to increase by using the pump. Means there are certain limitations for the pump to increase the pressure on a hydraulic fluid. Beyond that, if there is a need to increase the pressure on a fluid, we go for the intensifier. And the next element, that is the valve. Valves are the devices which will regulate the flow. Such valves are called as the flow control valve. There are certain valves which will regulate the pressure. They are some category of the pressure control valve. And in certain cases, there will be a requirement to regulate the direction of the pressurized fluid in order to carry out the different operations, mechanical operations. So, in order to control the direction, the valves those are using, they are come under the category of a direction control valve. This is the brief content of the chapter second, pump type working, its characteristics, system components, where you have to study the accumulator, intensifier, their types, working, symbols, applications. Then hydraulic pressure control valve, direction control valve, and flow control valve. We have seen all these elements in detail one by one. In last lecture, we have already started the hydraulic pumps. The hydraulic pumps are the devices which will use to convert the mechanical energy into fluid pressure energy. So the working principle, if we are considering, these hydraulic pumps are categorized into hydrostatic pump and hydrodynamic pump. If we are considering the displacement as a criteria, these pumps are classified as a constant displacement pump and variable displacement pump. If the construction is to be considered as one of the criteria for the classification of the hydraulic pump, it will be categorized into gear type, vane type, piston type, and screw type. If especially gear type pump is to be considered, it will become under the category, it will be classified as external gear pump, internal gear pump. Vane type pump, if we are considering, it will be a constant displacement and variable displacement. If piston type pump is considered, it will be a radial displacement and axial displacement. If axial displacement is to be concerned, it will become under the switch plate and bent axis drive pump. And last one, that is the screw pump. It is again one type of a positive displacement pump. In last lecture, we will take a brief review on gear type pump. Mainly, it is consist of two spur gear. It is mounted on two different shafts. One of the shaft provided with a drive from the prime mover. It may be a electric motor or engine. Another shaft which is having another spur gear. Drive is given to the one shaft and another shaft is driven due to the gearing action between these two gears. And these two gears are enclosed in a thick enclosed casing. This will be the airtight thing, right? There will be a minimum clearance between the internal surface of the casing and the teeth of the gear. And this casing or housing of the pump, it is having a two ports. This will be the inlet port for the suction of the fluid, and this will be the discharge or outlet port for the delivery of the pressurized fluid. When this pump, when this gear, it will be start rotating. At that time, at the suction side, there will be a space. It will be generated where the pressure between the atmosphere and the pressure at the space between the two teeth and the casing, there will be difference in a pressure. At this location, we are getting the because of during the gearing, when this gear is unmeshing, at that time vacuum is generated over this space. So this suction of the liquid it will be takes place, and the liquid it will be get trapped between the pockets between these two teeth and the casing. And due to rotary motion, that pressurized fluid it will be discharged at the outlet of the gear pump, where fixed amount of the pressurized fluid it will be supplied to the discharge of the gear pump. This will be the external type gear pump, external gear pump, right? Because these are meshing externally. Another part that is the internal gear pump, where we are mounting a one spur gear on a shaft, and there will be another gear ring which is having the internal teeth, and this spur gear is a meshing in the internal teeth of the gear ring. And what is it? It will be called as a crescent, this brown color, which will differentiate from this spur gear and internal gear teeth, right? This spur gear it is mounted on this shaft. When this spur gear is rotating, and when the unmeshing of the teeth it will be takes place over here, at that time the vacuum it will be generated over here. So this dotted portion, what it indicates, this will be the inlet port, and this fresh fluid from the we may say reservoir, it will be come into the pump. It is having a low pressure, and that will be trapped between the these two teeth and the spacing, this pocket. In this pocket, the fluid it will be get trapped, and it will be passing towards this discharge side. It will be get trapped over here. This arrow it will be shows that that fluid it will be get trapped between the space between the teeth, between the internal teeth and the external teeth and this crescent element, right? See here. So this trapped fluid it will be passed through this. We may say this dotted line it will be show the thoroughly pocket for the discharge, and combined discharge it will be passed to this outlet of the pump. So gear pump it will providing the fixed amount of the fluid flow at every rotation of the drive shaft. So it will become under the positive displacement pump. It will become under the positive displacement pump. There will be another one type we may say that the gear rotor pump. It will be same as like this gear pump, but there will be difference between instead of this gear, they are having a certain shapes like a lobe shape. It will be called as a gear rotor, right? And that will be utilized to transfer the fuel. The another element that is the vane pump. Vane pump it is utilized when we have to supply the constant amount with the increased volume. At that time, we will go for the vane pump. If we are considering this vane type pump, there are three types of the pump mainly: unbalanced vane pump, balanced type vane pump, and variable delivery type vane pump. This is the figure. It will show the unbalanced type vane pump. Why it is called as unbalanced type vane pump? Because if you are considering this construction of the vane pump, it is having a casing, right? And it is having a circular cam ring. There will be one shaft. On this shaft, this will be the rotor, and this rotor is having a certain slot for the mounting of this vanes, and these vanes are supported by the compression spring at the base. These are the springs. These are the springs, and this portion it will be act as and this rotor, the shaft of the rotor, it is somewhat eccentric from the center of the this circular cam. What happens when this rotor is rotating from the inlet of the pump? The fluid it will be sucked within the space between these two vanes because the vacuum it will be generated when this rotor it is at a lowermost position, right? When this rotor is rotating in clockwise direction, what happens? It will take the upper position. At that time, whatever the fluid, it will be trapped between these two vanes. It will be get compressed or pressurized, right? And these vanes are compressed within this, we may say, slots, radial slots. Those are provided in a rotor, and these vanes are compressed against the spring force. So that pressurized fluid it will be transferred as this rotor is rotating in a clockwise direction. This pressurized fluid it will be transferred to the outlet. Due to this unbalanced type rotor or eccentric rotor, what happens? Side load is obtained, and there will be a load on a bearing. Side thrust is obtained. For that purpose, this type of the vane pump it is called as unbalanced type vane pump. In order to overcome the limitations of the unbalanced type vane pump, that is the unbalanced type vane pump. In unbalanced type vane pump, because of the pressure difference at the inlet and the outlet ports, it will create the load on a vane and side load on a rotor shaft. In order to avoid that a side load on a bearing of the rotor shaft and the load on the vane, we are making certain arrangement or changes in an unbalanced type vane pump. What changes we have made in this type of pump? Instead of a circular cam ring, we are having a vane cam ring. And instead of providing a single inlet and outlet port, we are providing two separate diametrically opposite inlet port and two separate diametrically opposite outlet port. Because of that, whatever the pressure difference it will be generated at due to the inlet and outlet port, it will be gets nullified, and remaining operation it will be the same. When this rotor is rotating at the suction side, the hydraulic fluid it will be enter in a pump and gets trapped between the pocket between two vanes and the casing. Between the pocket between the two vanes and casing. As this rotor it will be rotating in clockwise direction, trapped liquid will be discharged to this outlet side. This trap liquid, it will be discharged to this outlet side, and at the outlet we are getting the pressurized fluid when this rotor is rotating in a clockwise direction. Here you must have to think that this rotor is not a eccentric rotor. The center of the elliptical elliptical cam ring, and the center of the rotor, it will be the concentric one. This is the balance type vane pump. The next point, that is a variable displacement pump. In certain cases, we are getting the fixed displacement. In previous pump, we are getting the fixed displacement of the hydraulic fluid by using unbalanced type vane pump and balanced type vane pump. But there, in certain applications, there will be a requirement of a variable displacement design or displacement of the discharge. Means in certain cases there will be a requirement of having a discharge from the pump, which is the which will be the changing. It will having certain variation. For that purpose, in a pump design, they have made certain provisions. There are two screws providing on right hand side and the left hand side of the pump. One screw, it will be a displacement control screw. It will control the displacement of the piston, right? Displacement of the piston. Because of that discharge, it will be controlled, and this will be the maximum volume adjustment. By adjusting that screw, we can adjust the offset or eccentricity between this rotor and the axis of the, we may say, center of this cam ring and the axis of this rotor. We can control the stroke, and by controlling the stroke we can control the displacement. This is the variable displacement type pump. Means whenever you require the different or variation in a flow rate or discharge, at that time we can control that discharge by controlling the eccentricity and controlling the stroke. We can get the variation in a discharge of the pump. So these are the three main type of the vane type pump. First one we have studied, that is a unbalanced type vane pump. Second one, that is a balanced type vane pump, and third one, that is a variable displacement design, where we can get the variable delivery from the pump. Variable means we cannot get the constant delivery. Means if you are considering 10 liter per minute, this will be the constant delivery. But in certain cases we require the up to certain period of a time we require 5 liter per minute. In certain time we require the 7 liter per minute. In certain time we require the 10 liter per minute. At that time we can just adjust the discharge rate by rotating the screw volume flow rate, or by rotating the screw the displacement or stroke, we can control the discharge, and whatever the pressurized fluid, it will be coming out from the outlet port. This will be the outlet port. Red color, it will show the outlet port, and green, it will show the inlet port. Here this dotted line, if you are clearly observing this, this will show the inlet port, for the inlet port, and this will for the discharge port. Are you getting? Yes. Vane pump.
Yes, sir.
Different types of vane pump, and it's working, right? Not present for this lecture. Only 20. Myself one. That is, 90 students are present for this lecture. For short period of time, we may take attendance, right? From TB, roll number 11. Is it present? Bapat Vinayak. Roll number 14, Deshmukh, Pratik Deshmukh. 21, Kadam. Kadam is present. I think Bapat, Vinayak Bapat is present, na? Hello?
Yes, sir.
Give the attendance, Vinayak.
Present, sir.
Okay. 32, TB, Nikam Saurabh. 39, Rai. 46, Shinde Deepak. 57, Avtade Yogesh. Avtade is present. 59, Bandare Pranav. 'Many students are absent. 61, Dehre Rupesh. 62, Nitin Ekamali. 63, Gaikwad Saurabh. 64, Vishal Gangthade. 65, Jadhav Sushant. 66, Jagtap Omkar. 67, Kohli. 68, Laute. Whether Laute is present? Dashrath Laute. 69, Londe Avinash. 70, Manya Akash.
Present, sir. Present, sir.
70 number, okay. Now TA, roll number 1.
Present, sir.
Okay. Roll number 2, Shraddha.
Present, sir. Present.
Roll number 8, Deep Jyoti. Roll number
Present,
9,
sir.
Rutuja. 11, Amol Thul. 11.
Present, sir.
Okay. 11, Amol. Amol is present. Roll number 12, Jnaneshwar Bansode. 13, 14. You might have known your roll number, right? I just called the roll number. Is it necessary to recall the name? Hello? Not necessary, na? 13 number. 14, 16.
Present, sir.
Okay, 16 number. Sawan
Present.
Saurabh, right?
Yes, sir.
17. Sawan Shreyesh, present. 22, Devkar. 23,
Present.
okay.
Present.
24, Todkar.
Present, sir. Present, sir.
25, Yash Gadekar.
Present, sir.
26, Prakash Gadge. 30, 28, 30, Satpute Rahul. 31, 32, 33, 33 is present. Kiran Hambirao. 34 Milind Jagdale.
Present, sir.
36 Prathamesh Daskar. 34 Rohit Khandagale. 41 42 43.
Yes, sir.
Which 43 का अक्षय का
42, sir. 42, sir.
42 Sachin.
Yes, sir.
43 44
Yes, sir.
45
Yes, sir.
46 sorry 47 48 49 52 53 55
Present, sir.
okay 55 present right
Yes, sir.
56 Akash 57 Pritam 58 Mahavir
Present, sir. It's Paras.
58 का
Yes, sir.
हाँ 59 शैलेश 60 ओंकार 61 62 63
Present, sir.
okay 64 65 Praveen 67 Kanaya 68 Chaitanya 69 Vallabh 70 Omkar Patil. Why another students are not attending this lecture? Any problem? Because last session. Hello.
Yes, sir.
Why students are not attending lecture? Whether this whatever we are discussing is understanding to you or not?
Yes, sir. Yes, sir.
Require more explanation.
No, sir. It is
Can we?
sufficient.
Huh? Sorry.
It is sufficient, sir.
Is it okay or not?
Yes, sir. Yes, sir.
Okay. The next type of the piston type pump. Next type of the hydraulic pump, that is the piston type pump. In piston type pump, we have to study mainly two types of the pump: a radial piston pump and axial piston pump. In radial piston pump, as like a radial engine, the piston and cylinder arrangement, it is provided radially, right? And in axial pump, the cylinders are mounted axially. As like in a actuators, we have studied the radial type actuators and axial type actuators. Same construction is there, only working is the working is changing. Where in case of actuators, we are converting pressurized fluid pressure energy into mechanical energy. But in case of a pump, we are converting mechanical energy into fluid energy, pressurized fluid energy. Here, this is the radial piston type pump. This will be the pump casing. These are the cylinders, and in that cylinder, this will be the piston, right? And these cylinders are mounted in this casing. In certain rotation, the fluid it will be get enter when this piston it is moving toward the center. When here, when this piston it is moving toward the center, at that time suction it will be takes place. At every cylinder, the same operation is to be carried out. When this piston it will be moved toward the center, suction it will be carried out. When this rotor it will be moved, right? At one location, what happens? This piston it will be moved away from the center. At that time, this discharge it will be takes place continuously. Means in case of a radial piston type pump, what happens? When the piston is moving toward the center, at that time suction it will be takes place to each cylinder, and due to this rotation of the shaft, right, or of the rotor, what happens? At a certain time, this piston it will be moved forward. This will be moved forward. Because of that, the, the fluid it will be sucked within the cylinder. It will be moved outside the cylinder, or it will be thrown out outside the cylinder. Means discharge it will be takes place simultaneously at each cylinder in case of the radial pump. Are you getting this operation? Is it understood by visualization? Yes.
Yes, sir.
This cylinder here, this one is the cylinder, right? And with the rotating shaft. Whatever this rotor, it will be rotating eccentrical. This will be the center, and this will be the rotor, which will rotate eccentrically about this shaft, right? Around this shaft. So, by using the radial type piston pump, we can transfer the fluid at from each cylinder by suction of the fluid up to a certain rotation, and by discharge of the fluid for another rotation of the rotor, because of a inward and outward movement of the piston within each cylinder. Now next type, that is a swash plate type axial piston pump. In actuator also we have studied this type of the actuator. In case of a swash plate type axial piston pump, what happens? This will be the drive pump and drive shaft. On this drive shaft, this swash plate it will be mounted, right? And to this swash plate, there will be a linkage by which we can connecting the piston, and that piston which will be reciprocating within this cylinder, right? And this will be the cylinder barrel. If you are considering, this will be the cylinder barrel. In the cylinder barrel, there will be provision for the reciprocating of the piston within the cylinder. What happens? We may say this will be the inlet and this will be the outlet, right? What happens when motion is provided to the drive shaft by using the prime mover? It may be electric motor or IC engine. This cylindrical barrel, it will start rotating, but this swash plate which is mounted on a drive shaft, it is having a certain inclination to this axis of this drive shaft. Because of that inclination, whatever the piston swash plate, they are having a certain linear variation, right? Because of the inclination provided to this slash plate. If the slash plate is a totally vertical at that time, all the pistons, those are having a constant distance from the slash plate inside this cylinder. But due to the inclination, the pistons within the cylinder, that covering distance, it may get vary, right? Because of the inclination, the displacement of each piston within the cylinder, it will be the vary, it will be the changing. If this flat plate is a vertical, the displacement, it will be the constant, right? So discharge, it will be get constant or minimum discharge you are getting. If you are increasing the inclination of a flat plate with respect to the axis of the drive shaft, at that time we are getting the maximum displacement from the pump. And in case of a swash plate, the maximum displacement angle, it will be maintained up to 17 to 18 degree. Most preferably, it will be a 17.5 degree angle. It will be maintained between swash plate and a axis of the pump. Here, this angle and axis of the pump. This angle, it will be maintained near about 17.5 degree. By changing the angle of the swash plate, we can change in the discharge from the pump. Instead of having inclination in this direction, we may provide the inclination in this direction. But by changing the inclination, we may decrease discharge from the swash plate type axial pump. One point you must keep in mind that in order to vary the discharge from the swash plate, you must have to provide certain inclination to the swash plate. If you are maintaining the swash plate vertical, there will be no flow from the pump. If the inclination angle is a positive, then maximum forwarded flow or maximum discharge, it will be obtained from the pump. If the swash angle, inclination of the swash plate with the axis of the shaft, it will be a negative one. At that time, we are getting the reverse flow. This is all about the swash plate type axial piston pump. Are you getting the working of this construction and working of this swash plate type pump? Yes. Here, if you are consider, this will be the cross section of this casing, black color. This will be a swash plate adjusting wall or screw. By using the screw or wall, we can adjust the angle of swash plate with respect to the axis of the drive shaft. And this will be the cylinder barrel, in which we are reciprocating this piston. Rotating cylinder barrel in which we are reciprocating this. The inlet, it will be stuck. When this swash plate, it will be moved outward. At that time, suction, it will be created over. Right? When this swash plate will be moving toward the right, at that time, piston, it will be moved forward in a cylinder block. So discharge, it will be take place. So continuous motion, it will be take place. And during the continuous motion, in partly there will be suction of the fluid, and in partly rotation there will be discharge of the fluid. It will be takes place because of an inclination of a swash plate. Are you getting? Operation of a swash plate type axial pump. Yes, reply. Any query?
No, sir.
Because your voice, it will indicate that you are tired or sometime boring. Is it or wrong? Hello, are you boring in this lecture?
No, sir.
No. Okay. In a bent axis type piston pump, what change they have made? Right? In bent axis type pump, they are changing. This will be the axis of the pump. This will be the drive shaft, and on that drive shaft, they are providing the flange. Uh, in previous slide, 1 minute. I think in actuators we have one better diagram. Construction it will be the same, only operation is different. See, this will be the motor we have seen, but in case of a pump, what change we have made? This will be the flange, right? And this will be the drive shaft, and there will be offset angle, right? When this drive shaft is rotating in certain cylinder passage, if you are observing these two positions, this flange it will be at a outermost position, and this side of the flange it will be a innermost position with respect to this moving cylinder block, right? And this one will be a fixed cylinder block, right? When this flange portion of the flange it will be toward the moving cylinder, at that time outlet discharge it will be take place, because this piston is moving forward or inside the cylinder. Whereas in upper portion, what happens when flange is at the outermost position from this moving cylinder? At that time, the piston is at the outermost position, so that vacuum it will be generated over here. So fresh, what we say, fluid it will be enter within the cylinder. What change we have made over here? Only we are providing this mechanical energy and converting this mechanical energy into fluid energy. This is the working principle of the pump. In pump, we are converting this rotary energy, the rotary energy of the shaft, that is the one kind of a mechanical energy. And that rotary motion of the shaft, it will be converted into pressure energy. We are getting high pressure fluid over here, where low pressure fluid from the reservoir, it will be sucked within the cylinder when piston is moving at the outward position. So vacuum it will be generated over here. And in the next position, when this flange, it will be at nearest to this moving cylinder. At that time, whatever the fluid, it will be sucked over here. It will be start discharge from this port, outlet port. Six plate त्याला किंवा six cylinder block म्हणतो आपण. Whatever the fluid, it will be get sucked in next position, or in during the rotation, in next half rotation, this piston it will be move in forward direction. Whatever the fluid it will be sucked, it will be get discharged from this outlet. This will be the operation of the, we may say, bent axis type axial piston pump. Are you getting the axis type axial piston pump? And these are the, we may say, certain cross section at this axis region. The axis it will be shows the cut section line, where we are getting the inlet and outlet manifold. If you are considering, this will be the inlet manifold and this will be the outlet manifold. Through this manifold, combinedly, we are supplying the fluid from different ports through this manifold to single port, and through from outlet manifold to outlet port. This will be the cut section it will show of this bent axis type piston pump. Are you understood the operation of the bent axis type piston pump? Now, screw type pump is one of the type of the positive displacement pump. In screw type pump, we are having the two helical. These are the helical threads. Those are mounted on a rod. So these are the two helical. Partly these are having a right helical tip and left hand and right hand helical tip, and those are meshing with each other. What happens when low pressure liquid it will be enter in this helical screw. Strap between the pitch between the two teeth, as like we are seeing nut and bolt arrangement, right? On on a bolt we are mounting the nut, right? And when we are rotating that nut, it will be moving along the bolt. Likewise, instead of a bolt, you consider that fluid element. The fluid element it will be work as a nut and it will be moving over the bolt. Likewise, provided to this drive shaft. One of the shaft it is providing a motion, so it will be called as a drive shaft, and another shaft it will be rotating because of a gearing action or threading action, right? When inlet fluid it will be enter in this casing, it will be get strapped and like a bolt, it will be moved along this thread. The fluid is moving toward this inlet portion. So at the inlet, uh, at the center portion, sorry, and at the center there will be provision for the outlet or for the discharge of the pressurized fluid. So this gear, screw type pump, it is a one type of the positive displacement pump where we are using the two metallic hardened helical screw. The screw are up to half portion they are right-handed screw and up to half portion left-handed screw. The two screw those are in meshing with each other, and out of these two screw one screw is having a motion from the prime mover. When screw is rotating at a suction side, the fluid it will be stuck within the pump, and during rotary motion the fluid it will be flowing along the screw as like a bolt which will be flowing as like a which will be flowing over the bolt, and it will become at the center where outlet port is provided, and at outlet port the discharge of the pressurized fluid it will be fast. The screw pump working across one pair of mating thread is de-pitched above. The liquid is similarly carried across all the pairs of mating threads. Here, whatever the liquid it will be entering from the inlet, it will be flowing along the screw between this gap and enters at the center from where discharge it will be take place. This will be the working of the screw type pump. The next point it is related with the certain characteristics, performance characteristics of the hydraulic pump in order to measure its performance. If we are considering the pump discharge pressure and rate of discharge, right? This will be the delivery, that is the discharge, rate of discharge, right? It will be indicated in a liter per minute, 4, 5, 6, 7, right? And outlet pressure, that is discharge pressure, it is in a kilopascal, 5,000, 10,000. And all these characteristics are plotted at a constant speed of the pump. Here, this graph, it will show the relation between pump discharge pressure, that is the outlet pressure, and pump delivery, that is the discharge liter per minute, when the pump speed is a constant one. What you are getting from this figure? As per as discharge pressure is the minimum one. Here, this will be the minimum value of a discharge, right? This is the minimum value of discharge, and at that time we are getting the higher discharge pressure. So as we are decreasing the delivery, right, the discharge pressure goes on increasing. This what this graph it will be indicates at a lower delivery. What are decreasing the discharge pressure? At that time, we are increasing the delivery from the pump. Means when the discharge pressure is less, at that time delivery from the pump it will be the more. Pressure versus power, efficiency, and rate of the discharge. If you have seen this chart, it will show the power requirement of the pump. Power, it is always represented in a kilowatt. It will be shown over this axis, right? But it is a delivery, discharge, rate of discharge. It will show the discharge pressure in kilopascal. On this will be the efficiency. Means at a higher discharge pressure, we require the higher power, input power for the pump. And another this efficiency line, mechanical efficiency line, up to 80%, volumetric efficiency line, up to 85%, right? It will be shown with respect to this delivery pressure. Means at every delivery pressure and how much is the discharge, it will be shown over this line. This is the kilowatt power input line, right? On this line, we are determining the power requirement of the pump, and with respect to the particular delivery pressure, we can calculate the mechanical efficiency. At 1000 delivery pressure, this one will be the mechanical efficiency, 80%. At 3000 delivery pressure, this will be the volumetric efficiency. Likewise, these are the some performance characteristics of the pump at a constant speed. The another characteristics, it will be related with the rotary pump. In rotary pump, if we are considering, this will be the discharge. This will be the delivery pressure or discharge pressure. On this axis, brake power, that is the output. This graph it will show the brake power. And this will be the shows the efficiency, and this graph it will show the efficiency of the rotary pump. From this graph, what you are observing, as the discharge pressure it will be goes on increasing, the brake power or output of the pump it will be moved linearly or proportionally. At certain discharge pressure, there will be a certain amount of efficiency. At this discharge pressure, this will be the brake power of this pump, and this will be the discharge of that particular pump at a particular discharge or at a particular efficiency. This will be the performance characteristics of a rotary pump. Now, centrifugal pump. As far as our hydraulics and pneumatic is concerned, we are rarely using the centrifugal pump, because centrifugal pumps are mainly used for high discharge with the low pressure. But what is our requirement? We require the high pressure with the low discharge in order to carry out the different mechanical precise operations. No problem. Centrifugal pump, it is a rotodynamic pump, and it is mainly applicable in a certain cases where we require the high discharge at a low head, right? Means in order to transfer the fluid from one location to the another location with a minimum head At that time, we choose the centrifugal pump. As far as centrifugal pump is concerned, as like a previous slide, there will be variation in efficiency, power, and discharge at a constant speed. Right? Here we are getting the discharge. This will be the pressure head of the centrifugal pump, and this will be the brake power, that is the output, and it will be measured over the scale output. And whatever the efficiency of the centrifugal pump, it will be measured over the scale efficiency. Right? As far as low head is there, maximum discharge it will be obtained. Then the certain typical characteristic curve for an external gear pump, it will be shown in this figure, where it will give the relation between the capacity or discharge of this external gear pump and the relation between discharge pressure and power output. So this diagram, it will show the relationship between capacity, discharge pressure, and power output, or we may call it brake power of this pump at a different RPM, 200 RPM, 400 RPM, right? There will be a change in power. It will be shown by this curve, right? And at a 200 RPM, 400 RPM, 600 RPM, this graph, it will be shows the change in capacity of this external gear pump. It will be shown by this graph. So in this way, we can study the different characteristics of the pump. For the, it will be related with the certain characteristics of a discharge pressure and rate of discharge, discharge pressure versus power, efficiency, and rate of discharge. Specific characteristics of some standard pump, that is a rotary pump, centrifugal pump, and external gear pump. So we will stop here. Is whatever the topic covered to today's lecture, is it clear or understood? Please reply. Hello.
Yes, sir.
Okay. Within a short period, we will take some question answer. Right. What are the two types of the gear pump? Anybody can give the answer? Types of the gear pump? Mangesh Misal. What are the two types of the gear pump? Is Mangesh is present in this lecture or not? Yes or no? Okay, Suraj is present. Suraj More. What are the types of the gear pump? Shraddha.
Yes, sir.
What are the two types of the gear pump?
External gear pump and internal gear pump, sir.
Okay, there is one another special purpose pump. It will be called as a gear rotor pump. Huh? Okay. Now, what are the two types of the vane pump?
Balanced and unbalanced.
Constant and variable displacement.
Between balanced and unbalanced pump. In case of unbalanced pump, there will be possibility of having a side thrust on a shaft or vane at suction and delivery side. In order to overcome that side thrust, we may make a changes in the fixing of the pump, so that we can nullify the effect of a pressure difference on suction and delivery side by providing two suctions on either side of the diameter. Similarly, two discharge on opposite sides of the diameter. Are you getting this? Okay. And in axial pump, right? Piston pump, sorry. In piston pump, what are the different types of the pump? Rotary pump and axial pump, right? And later on we see the characteristics of the pump. Okay, I think this will be the sufficient for this today's lecture, last lecture. It will be some hot, all of you are get tired for continuous attending the lecture. We will stop here. Thank you very much. If you have any doubt, please ask regarding this lecture, or we will stop here. Okay, thank you.